Okay, here are the solutions to the 3.4 activity about limits at infinity. So the first question says find the following infinite limits. The first one is limit as x approaches infinity of a ratio of two polynomials. When I see this, I don't care what those polynomials are beyond the first term, really. And I see that those are both fourth degree polynomials. And from what we saw in the activity, the limit here then, because they are the same degree, is going to be the ratio of the leading coefficients. Leading coefficient of 3, leading coefficient of 6. So this limit is 3/6 or 1/2. Okay, second one is the limit as x approaches infinity of sine of 1 over x. Well, I can take this one piece at a time. The x that's changing is going into the argument of the sine function. So as x approaches infinity, what's happening to the argument of sine? 1 over x is approaching 0. And I know sine of 0, which is 0. So this limit would be 0. All right, so this next one looks a little bit different than what we saw in the introduction. It's the limit as x approaches negative infinity of the square root of x plus 4 plus x. Okay, this looks like under the square root, I square something getting really big, negative, it's going to be positive. So this term right here is approaching infinity. And this term then is approaching negative infinity. So I get this situation that looks like infinity minus infinity. And I might want to say that that's 0, but I can't with any certainty unless I do some more work here. There are situations where one of those infinities is outracing the other one, or they're maybe approaching infinity at a similar pace and some number comes out of this, so we can't jump to that conclusion. So just like we've done when we've evaluated limits in the past with square roots, we're going to multiply by 1 here, and we're just going to change that sign in between it from positive to negative. So here's our multiplication by 1. When we do that, in the numerator, we get x squared plus 4 minus x squared. Middle term goes away, that's why we changed that sign there. And then we get the square root of x squared plus 4 minus x in the denominator. So that numerator simplifies to 4. Now what's happening in the denominator, this term is approaching infinity still, and this term is approaching negative infinity, which is just, oops, I wanted to write another negative, which is just infinity. So this denominator is approaching infinity. So we have 4 over something getting really big, which is going to approach 0. So it turns out in this case, infinity minus infinity is 0, but don't rely on that. It's not a truth all the time. Okay, the second question says find all the asymptotes of f of x equals the square root of 1 plus 4x to the 6th over 1 minus x cubed. All right, so to find all the asymptotes, we have to look at the limit as x approaches infinity, x approaches negative infinity, and then we have to think about the vertical asymptotes as well. And so we multiply, same game we played in the introduction. We multiply by 1 in the form of 1 over x cubed over 1 over x cubed because it's the highest power of x in the denominator. We rewrite the 1 over x cubed in the numerator as 1 over x to the 6th. And then we can go ahead and divide. And because we're going to negative, because we're approaching positive infinity here, there's nothing to think about in this step. We're good because everything's positive. Okay, and now we can divide. So we get the limit as x approaches infinity of the square root of 1 over x to the 6th plus 4. And then we get 1 over x cubed minus 1 in the denominator. And as x approaches infinity, this term's approaching 0, this term's approaching 0. So we're left with the square root of 4 over negative 1, which is negative 2. So that means we have a horizontal asymptote at y equals negative 2. Okay, we have to do the same thing now for as x approaches negative infinity. And now here we do have to think a little bit. So let me change colors. As x approaches negative infinity, 1 over x cubed is less than 0. Right? X's are negative, cube them, they're still negative. But 1 over the square root of x to the 6th, that is greater than 0. The square root always defaults to something positive. Take something negative, raise it to the 6th power is going to be positive, and then take the square root of that. So to maintain equality, 1 over x cubed is going to equal negative 1 over the square root of x to the sixth. So this is then the limit as x approaches negative infinity of the square root of 1 plus 4x to the sixth divided by 1 minus x cubed times 1 in this form, negative 1 over the square root of x to the sixth divided by 1 over x cubed. Now both of those terms are negative, and so that thing is equal to 1. And so we're good to make that algebra move because we're not changing the value of the limit. This negative sign can just come out in front here, and the square root in this numerator simplifies to 1 over x to the sixth plus 4 over 1 over x cubed minus 1. Awesome. Limit as x approaches negative infinity. I think we're good to go here. This limit is 0. This limit is 0. And so what do we get out of this thing? We get negative square root of 4 divided by negative 1, which is 2. So that gives us a second horizontal asymptote. Y equals 2, and that asymptote comes into play as our x's approach negative infinity. And the horizontal asymptote of negative 2 is as x approaches positive infinity. All right, I guess technically to finish this off here, we would need to ask what the vertical asymptotes are. And in this case, that's going to be when the denominator is equal to 0. The denominator is 1 minus x cubed. So that's going to happen when 1 minus x cubed is equal to 0, and that only happens once, when x is equal to 1. So there's your vertical asymptote. It's the line x is equal to 1. Okay, see if you can head on into the homework that's assigned in the book for section 3.4.